You know, when you write a book, you kind of hope someone will say something like that. So thank you. That was what I was going for too. So okay, let me get this warmed up here. Okay. Excuse me for just a second. Oh, I will mention as we get started here too that I brought some copies of the book, which I will sell for $10. But any book that I sell, I will be giving the proceeds right back to the Austin Oasis. I mentioned as a surprise. So if you do buy a copy, it's my pleasure to help support the group here. Okay, wow. Well, indeed, my hope is to blow your minds this morning, so let's see what we can do. So let's start here. I'm going to hit you very quickly. Actually. There we go. So here we have a dog, intelligent, lovable, and teachable. But here's something a dog just can't grasp. The number 10. Okay. Dogs, like many animals, can grasp the concept of more to some extent, but there's no evidence any animals can distinguish between, say, 9 and 10. And they certainly can't calculate 1,000 minus 100 equals 900, understand anything about it. The cognitive ability just isn't there. Now, there are many examples of cognitive limitations of animals, but for my purposes today, just one is all that we need to make the point. Okay, but that's not the key point that I want to make. So what is my purpose? What is the key point? It's not that humans are cognitively far beyond animals, which in fact we are, and that's something really worth thinking about. What I'm trying to do is make two big points. Okay. First, there are real things in our universe that dogs and other animals simply can't comprehend. And notice the emphasis here on real. There's nothing mysterious here. We all know what the number 10 is. It's very real to us, and in fact, not even very complicated. So, second, we need to think for a moment a little bit more deeply about what can't comprehend means. It's not if dogs and other animals know they don't understand numbers. They don't sit around thinking, I've got this concept of the number of fingers on two hands. I just don't know what to do with it. That's really not the case. They just really have no concept of the number 10 at all. It just doesn't register in their brains. Numbers are simply beyond their cognitive capabilities, what their minds are capable of grasping. Or, as I put it here, can't comprehend means they don't even know what they're missing. So far, I haven't said anything controversial. It may take a little while to sink in because we don't typically think about this. But so far, really, I've just made observations. But now I'm going to propose something, offer some hopefully interesting arguments in its favor, and then let you come to your own conclusions. Here's my conjecture. There are real things in our universe that humans can't comprehend, things we don't even know we're missing. Now, it really does take a little time to digest this. Our perspective on the universe is through that which we can comprehend. How can there be real things we can't comprehend? Well, two arguments. First, humans are animals too, with very specific physical limitations. The mature human brain weighs about 3 pounds. Humans have certainly evolved far beyond other animals, but have we evolved to a point where our minds are capable of comprehending everything real in the universe? Given that when we look at every other species on Earth, without exception, there are real things they can't comprehend. It seems we're probably in the same boat. So, secondly, while it's true that we can't comprehend what we can't comprehend, I'd like to suggest that we can, in fact, see metaphorical shadows that provide evidence of things we can't comprehend. Now, we can understand where this shadow came from because we can see now where it came from. But the shadows I want to talk about don't help us understand the incomprehensible. They don't help us understand it. They simply make us aware that things beyond our comprehension exist. So now, what I'd like to do, to have a little bit of fun, is try to share some of these things, some of these shadows with you. Okay, Evangelista Torricelli. He was a contemporary of Galileo, and went on to make many contributions in science and math, and in many circles he's credited with actually having invented the barometer. But one discovery in particular helped secure Torricelli's reputation. In 1641, he produced a container that confounded mathematicians and philosophers alike. So this is Torricelli's trumpet. It proposed a container that, when you lay it on its side, it looks like an elongated horn, which is why it's sometimes called Torricelli's trumpet. It's also known as Gabriel's horn in other books. What's special about Torricelli's trumpet is that it doesn't actually end in a mouthpiece. Instead, the horn gets ever smaller, but never actually comes to a point. At 1 on the measuring stick, well, it's a foot. At 2, the diameter is half a foot. At 3, a third of a foot, and so on. So you could see that it would get ever smaller, but it would never actually close, no matter how far out you went and stopped in 1 millionth. Doesn't actually close. So, reoriented like a container, it has no bottom. A dimensionless water drop, which is something mathematicians like to work with, would continue down the trumpet forever. Torricelli was able to show that even though the trumpet has no bottom, its volume is finite. It holds a little less than 6 gallons. If you try to pour any more in, it'll come spilling over the top. Torricelli's peers were truly astonished. How could an infinitely long container with a hole in it have finite volume? Even Torricelli appreciated the broad repercussions of his work, referring to his discovery as paradoxical. The idea that a bottomless container could have finite volume didn't make any sense to the people of the time, and it still doesn't. Okay. Now, no panic. I put this up simply to make a point. In fact, the point is that the calculation isn't even particularly complicated these days. It falls right out of integral calculus. It was very new many centuries ago. In fact, it's something first-year calculus students not only perform, but frequently do. But the students, even though they do it, are rarely encouraged to stop and think about the perplexing nature of what lies behind the pencil strokes, because we mathematicians have become so familiar with it. But they should feel free to be perplexed. They should stop and think about what they're doing. Interestingly, the fact that Torricelli's trumpet has finite volume has kind of lost its luster over the years, again, primarily because mathematicians have grown used to it. But the trumpet still captures the popular imagination, but for a different reason, and a reason that was unappreciated in Torricelli's time. I don't know when it was first discovered. I can't find the history on that. Not only does it have finite volume, it has infinite surface area. The volume is 6 gallons. The surface area is infinite. Okay, let's stop to think about that for a moment. Okay, so let's calculate the volume and surface area of this box. It's 1 foot on a side, so it would be 1 cubic foot. 1 times 1 times 1. Each side is 1 square foot, and the bottom is a square foot. So we have 4 sides and a bottom 5 square feet. Okay. Now, let's suppose that we pulled out our tape measure and performed the same procedure on Torricelli's trumpet. Hypothetically, of course, because it's a little too big to get at. In this case, we'd find a volume of 6 gallons, about 8/10 of the cubic foot. But when we tried to measure the surface area, we'd find that it was infinite. We couldn't get around to doing it. So, although somewhat imprecise, it's frequently observed that while the trumpet can be filled with paint, the prospect of painting it seems challenging, to say the least. So whenever the Spirit moves you, feel free to be very perplexed. I see a couple of heads shaking. This is my goal. Okay. I'd like to now turn to an entirely different conundrum. To set the stage, let's go back to 1927 in the now famous 5th Solvay Conference in Brussels. It was an amazing group, 17 of the 29 participants would win Nobel Prizes. You can actually notice here, it's interesting too, there's actually one woman sitting here. It's Madame Curie is down in the front row. Not sitting next to Einstein, but very close. Okay, the meeting amongst these luminaries was to discuss one particular philosophical question about quantum theory. The math of quantum theory works remarkably well. The problem lay in the physical interpretation of the math. So as a background, let me make an observation about waves and particles. Okay, so we all know particles. Particles like balls, bullets, rocks, electrons, and so on are quantities of mass, and they deliver their energy with a thud. When you get hit with a rock, you know you've been hit with a particle. Okay. Now, waves are actually a little bit different. Oh, I'm sorry. There was this. So waves are a little bit different. They carry energy through a choreographed dance amongst the particles that make up their transmission medium. For example, water molecules that make up this water wave jostle each other as they carry the wave's energy through the water, but they don't actually consist of particles moving from one point to the other. Now, the waves, as they crash upon the beach, you actually do get the particles. But if you're out in the middle of the Gulf of Mexico, there's a lot of energy being transferred through those waves, but nothing's actually moving. It's kind of passing it on. There's no particle. And in fact, as you're in the wave, you don't feel like you're being hit by a rock. You can just kind of feel the gentle motion of the wave, even though there's an incredible amount of energy being carried through. So the key point is that particles and waves are two entirely different things. Everybody knows that. Physicists know that. It's not still people. That's it. Okay. But the problem is that things like light, electrons, protons, and even much larger particles behave like both. If we want to run one experiment, the results force us to definitively conclude that, say, an electron is a particle. End of story. That experiment says it's a particle. If we then run another, the results force us to definitively conclude that an electron is a wave. Definitively, no question about it. End of story. Now, since quantum mechanics first emerged, many physicists, philosophers, and other thinkers have grappled with understanding its physical reality. But I think the world-renowned physicist Richard Feynman summarized our understanding best when he said, I think I can safely say that nobody understands quantum mechanics. And quantum mechanics and actually today's physics is a world of all sorts of weird stuff that is inexplicable in certain ways. And today, physicists typically talk about, in fact, do I have the slide on it here? They typically talk about the wave function collapse. So in fact, it's kind of as if particles kind of exist in a wave state. In fact, they will say this, it's in a wave state, and then we go to look for the particle. The act of observation causes it to collapse into a particle. And then when we stop looking, it goes back into a wave state. Those are actually the words that physicists will use to describe things. They don't even try to get around it. They just say that. So it's quite remarkable. Okay. So turning to yet another conundrum, throughout the latter half of the 20th century, scientists were puzzled by a disorienting observation. Galaxies were rotating too fast. There wasn't enough gravity to hold them together. At the speeds that they were rotating, there didn't seem to be enough matter to create enough gravity to keep them together. The rotating galaxies should have been flying apart. Now, at first, scientists thought the missing matter might be burned out stars and other debris that we couldn't see because it was just dark, and that came about the name dark matter. But further observations determined that conventional dark matter wasn't there. So rather than give up the theory of gravity, as described by Einstein's general theory of relativity, scientists postulated the existence of exotic matter lurking in the background. And here again, exotic is the technical term that's used. This exotic matter has the property that it exerts gravitational force, but otherwise we can't see, hear, smell, taste, or feel it. It's beyond the realm of our senses. Yet it's widely accepted that it exists and that it's roughly 5 times more abundant than regular matter. I think dark matter is actually a case where scientists have basically said, here's something beyond our physical comprehension, but we believe it exists. So this is my last example, and then I'll wrap things up and have some talk if we want to. What I want to do here is introduce you to a special recipe, and I know it's kind of small for you to see out there, so I'll kind of read what, basically just 8 ingredients here. But it starts with 14 gallons of water, 1.5 gallons of carbon, 9 cups of frozen nitrogen, a few cups of calcium, phosphorus, potassium, half a cup of salt, sulfur, and half a cup of salt. We're going to mix it all together. We do need pinches of about 10 more ingredients, but they're really tiny. And when we mix them all together, we have a 150-pound human. I think most of you have probably seen something on this order, so it doesn't come as a big surprise. But again, it's another one of those things where we kind of hear it, it goes in our brains, and then we don't think about it much anymore. It's really a perplexing question. How on earth does all this lifeless stuff give rise to life? How does it give rise to consciousness and all those internal sensations that go along with it? So even those that have trouble with consciousness, free will, philosophers, they still stand to say nobody really understands what's called, in philosophy circles, the hard problem of consciousness, which is, why does it exist in the first place? Okay, so, does anybody know where this king comes from? That's right, too. I always want to make sure. Okay. It's a core oasis value, and it's a core personal value. Reason, rationality, and logic are 3 of my favorite words. But in light of what I've shared this morning, which is evidence supporting the conjecture that there are real things in our universe that humans can't comprehend, let me pose the following question, which I'll say in advance is in no way contradictory to this value. And that is, can all reality be known through reason? Okay. Or does reason itself lead us to conclude that there are real things beyond the realm of human comprehension? Things beyond our comprehension. I think it's actually a very important point, and especially for the scientific community to keep in mind. And I'm going to explain why with an example, and then we'll wrap up. Okay. It turns out that the working of the universe depends on a handful of numbers that seem to come out of the blue, like the speed of light and the gravitational constant. These numbers are called the constants of nature. And further, scientists agree that if many of the constants of nature were ever so slightly different, life in the universe would not have developed. We live in an extraordinarily well-tuned universe, hospitable for human life. And how do scientists account for this? By the way, John Wheeler, right here in town, was one of the people that used to talk philosophically about why the constants of nature were as they were, as many physicists have, but Wheeler in particular. Okay, so the common scientific argument goes as follows. There are infinitely many universes constantly popping into and out of existence, each with different constants of nature. In most universes, the constants of nature don't support life, but in a tiny, tiny fraction, by random chance, some do support life, and we just happen to live in one that does. Now, they actually take this a bit further, which is, again, this is from just a purely logical standpoint, it's interesting to follow. Here's the following video. They say further, and this really takes some thought, if the universe we're in didn't support human life, we wouldn't be here to ask the question. Okay? So it's turned things upside down here. So we shouldn't be surprised the constants in our universe support human life, because in any universe where life exists to ask the question, the constants must speak such that they support human life. It's actually correct. It's a reasonable. There's nothing wrong with the logic in it, but it does kind of stand things on its head. You have to kind of think about it. Okay. And in fact, I just added this line this morning, but the late physicist Stephen Hawking held this position. And the physicist David Deutsch, excuse me, I need to get this. Sorry to hold that up. Physicist David Deutsch writes in his book, The Fabric of Reality, quote, "The theory of parallel universes is not the problem. It is the solution. It is not some troublesome, optional interpretation emerging from arcane theoretical considerations. It is the explanation, the only one that is tenable, of a remarkable and counterintuitive reality." Okay. While I understand Deutsch's logic, I believe that the argument falls short in many ways. Among the most significant shortcomings is that it posits the existence of infinitely many universes nobody believes we'll ever be able to see. So it pops out of mathematics, and we say we have infinitely many universes, and this is what goes on, but we'll never see any of them. Okay. Scientists who embrace multiple universe theories believe what they do because they can't conceive of any other scientific explanation. But here's what I would ask. Are such extravagant theories warranted, or is it more reasonable, more scientific, and just simpler to accept that there may be explanations of which our limited human minds just aren't capable of conceiving? I'll throw it out and let you think about it. So we often tacitly assume that everything real is knowable, that we just have to work hard enough to understand all that is. I think the scientific community, we move forward with that. It's very reasonable. It certainly is a heuristic. But given our 3-pound brains, isn't that possibly a little presumptuous? And what happens when our seemingly best explanations lead to conclusions that erode the human spirit, or even erode human spirituality? I believe deeply in the scientific endeavor, but on issues including human-machine intelligence, free will, and the very existence of the universe, it seems to me that we're probably in over our heads a little bit. As we learn and discover, it's important to keep in mind that our best scientific explanations may at times be self-deceptions simply because we're up against things we're not wired to deal with. Recognizing this compels us to face life with a bit more humility. We live in an astonishing world, and it's quite likely even more astonishing than we'll ever comprehend. So thank you for letting me share with you this morning.